Welcome back. Now let us do the hands-on on logistic regression, and there have been the many techniques, many algorithms for logistic regression, and I've seen this logistic regression for almost good number of years. And logistic regression, as I had explained during the concept, is the classification technique where you predict the two levels, 0 and 1. So classification you can do with multiple things, using the random forest, using XGBoost, or is the traditional logistic regression. So there is a traditional logistic regression library also. What I have observed that if you do this logistic regression using XGBoost or random forest, it has the better accuracy than the traditional one, and that is why for learning purpose here I am using XGBoost. You can also use the random forest or any other technique. So because the concept is same, okay, so it does not matter whether you use XGBoost or random forest, but concept is same. So let's start. 108, we are reading the data fresh, and since 113 we are doing that we are keeping only two outcomes, because logistic regression really works with only 0 and 1. So we are keeping only two levels. One is Setosa, one is versicolor. That is what. And what we are doing, we are encoding that if it is Setosa, then make it 1 and other is 0, just for so that 0 it become data become 0 1. And this is the cutoff. For timing, let it be as it is, and I will explain you what is the use of this cutoff. What is the use of this cutoff? Right now, simply run this one. I will explain you at the end that what is the use of this cutoff and how you can really change the cutoff depending upon the business outcome. Plus, how can you take the balanced data for the cutoff depending upon your data plus the business outcome. Okay. Now, this partition of data we have explained multiple times, where we are segregating the data, train and test, and 85% is the training data and then 5% is the test data. So if you see that 86 rows out of 100, 86 is training and around 14 is test. Okay. Here is the typing mistake. Okay. Good. So we are going to use the XGBoost. So that is what the line 129 is the library. 131 we are getting list of all the predictive variables. 132 we are simply converting to formula because XGBoost needs the formula. And 135 we are converting to the D matrix, which are very much specific to the XGBoost. And XGBoost does not understand data frame or the any simple matrix, so it understands its own form, that is called D matrix. 135 we are converting data into that format. 136 we are simply keeping the number of row and column. This is number of row, number of column, and removing the previous data because we don't need anymore. 136, okay, and so it is the we are working with default parameters, and this default parameter I had already explained earlier. Okay, and these are the number of ports, so that in the case of it can move the parallel. And now start seeing the what is we are going to work with, say 86 number of rows and F5 columns, and these are the various parameters we are going to work with. 146 we are building the model. So this has been done because it is a small data, so it did hardly less than a second or so. 147 we are saving the model so that we can use in future. And 149 onwards we are predicting self prediction, basically prediction on the trained data. And once you predict trained data, it's a very I think the here error will be almost less than 1%. Okay. Now, okay, come, that is fine. Now, if you see this prediction which has been done, so I'm just trying to predict that what it is. The print it is. If you see this one, all this, what this is, this is the between 0 to 1 score. Okay, and you can also while prediction, if you want the probability of each one, it can, there is some way. Okay, so there is some way. One more thing, if you see the, while building the model in this one, what is the objective? So we have used the objective regression.logistic. So in case of regression.logistic, it gives the score between 0 to 1. If you use that objective multi underscore this software, it will give you the probability for both. Two different column will come, probability of 0 and probability of 1. So depending upon that objective, you will get it. So first you learn it, and then you can try this one on your own. Okay, you can try this one. So here we were, now this is the score we have got it, that is between 0 to 1. Here I was saying you the cutoff. So how to decide what should be the cutoff? So not necessarily every time you will be using the 0.5. You should be using, I'm going to explain the cutoff part here, which we have here in 119. So what it is taking, I'm saying if it is taking total number with data 1, where it is 1, and what total number of records. So it is the, right now it may come around 0.5. Let me print it here because we have 50-50. But it may happen that in the practically the data you are working with, you have say 70% 1 and 30% 0. So that time it become 0.7. And I had explained that if you see that in case of fraud, I had given you the example that suppose you have working with the data where 90% are genuine and 10% are fraud. But it may happen that see, your data may not, your model may not be the perfect. So it may happen that even though you have the 0.9 as a cutoff, still a few genuine people are marked as a fraud, so which is not right. So you can make it more tough. If on the data say 0.9 as a cutoff, you can make the cutoff 0.97. And that is what I was saying, that even the data it is saying 0.5, but you can change it as per the business requirement and see the what kind of problem you're trying to solve. So in case of fraud, say it says the 0.9, but from the business point of view, you can make it 0.97 by hard coding it, okay, or by putting in a configuration parameter. That is what this cutoff is important. And now once this cutoff is there, so we can definitely, if it is greater than cutoff, 1, if it is less than cutoff, 0. So 154 we are making the prediction in 0 and 1. So it has become, if you see now, if you print this one, it has become 0 and 1. Okay, and so here let me make it so that at least it becomes easy to read. And okay, good. Now we are extracting the actually was already here in the D matrix. So, and the feature name was also over here, and removing the data that trained because we don't need. So we are running 158. In line 158, 3-4 things are happening. We are getting the actual. We are getting the feature name. I'm just clicking here. These are the feature names. Okay, and this is cleaning up the data. Now classification summary, this is the one utility function written by me in common util. So when we click this classification summary, it is giving the confusion matrix. So since it is on the trained data, so that is why confusion matrix is perfect, accuracy is perfect, kappa is perfect, and so on. And the sensitivity is perfect, specificity is also perfect. These are almost perfect. Okay, that is good. And the variance, this importance matrix I had explained earlier, that 144 and 165, it is writing the importance matrix. In this file you can see which all features are important. I have already explained this one in the previous video. Now 168 we are going to do the prediction on the test. So simply taking the number of row and column. 169 we are converting test data frame to the text D matrix, and 171 simply printing. 172 we are predicting on the test, so this has again given us the score. And 175 we are going to use the cutoff to make it 0 1. 171 we have done the classification summary, and if you see, this is the summary. So all the 0 1, it looks like here also the prediction is perfect. So this is called good model, because on the test, if the confusion matrix is almost perfect, accuracy is perfect, kappa is perfect, sensitivity is 1, good, specificity is 1, that is what the good model. But in practically you may not get it. So whatever you get, say 90% or so, and if that is making your business expectation, then that is a good model. Line 81, clean up. That's all. So this was the concept of this logistic regression using XGBoost. And I reiterate, you can implement logistic regression even using random forest and few other algorithm as well. You can also use the classic logistic regression library, but only thing I find that XGBoost and random forest has been one of the best, or basically good. It is providing good accuracy with current complex data which we have been seeing it. So it is my advice, although choice is on you. You can use it as per your depending upon your data. So that's all for this one. See you in the next one.